Now this is the list in which the attributes are checked. So until there is a tie break, it will check. Until there is a tie break. For example, you see the very first line on the top. Considers only synchronized route with no AS loop and valid next hop. And then only it will go to the first attribute. See, before first attribute, we have this condition need to be met. The next hop given by your neighbor need to be valid next hop. Let us go and check whether that is true in our case. Here is our topology. I'll go to router 1 and see whether I'm learning show IP BGP. Is this a valid next hop? Is it a pingable next hop? Yes, ping and see. And is this a valid next hop? Yes. Now, to reach 68 network, which is on R8, you see, R8, autonomous system 40. You see, autonomous system 40. From autonomous system 40, it is sent to autonomous system 30, which is here, router 5. From router 5, it came to router 3, and in router 3, because we said next hop self, router 3 address is now here given to router 1. This is a reachable next hop. Same way, that same network 68 also enters router 20, but through redistribution. I means using network command, internally BGP is advertising. Whereas this one is from some other source, it is advertising, means redistributed. And it is coming via router 4, which is in autonomous system 20. And from router 4, it enters router 2. In router 2, you have said next hop self. So you are learning this network from both router 2 and router 3. It prefers going via router 3. It prefers to go via router 3, which means router 3. How do I know? Because I see this greater than symbol. I'm seeing this greater than symbol for this update with the next hop of router 3. Even if we check in the routing table, show IP route, you will see only router 3. Even though you have another route which is shown in the BGP table, you don't see that in this routing table. You remember I told you, among multiple paths, BGP will pick only one path. BGP will never do equal cost load balancing or any load balancing. If you want, you have to do something manual. BGP is not designed to do load balancing. It won't do. Now, if I shut down a neighbor, say for example, I'll go to router 5. I'll shut down this neighbor. After shutting down, I'll come back to the same command on R1. Then you will see it will shift to router 2, which means both the paths are valid, which means the first point is this point is successful. This first point is a tie. First point is not a determining factor. To decide on the best path, something else is going to be a determining factor. Now let me go to router 5. As I said, I'm going to shut down this neighbor. This is the address of router 7. In which router I am in, Bala? In which router I am in? Router BGP 30. This is the autonomous system of router 5. And say, neighbor this, shut down. This is how we temporarily shut down a neighbor. You don't need to remove completely. You shut down. After I shut down, as I said, I will take you to router 1. Earlier when we were checking, it was going through router 3. And the number of hops was 2. Autonomous system 30 and autonomous system 40. And what else? Now, if I check the same command, it is going via 2. Here the route tag is via autonomous system 30. Here route tag is via autonomous system 20. You see, failover has happened automatically. Which means BGP finds this also as a best path. Now you read the first line. Considers only the route with no AS loop and a valid next hop. If there is an AS loop, then you won't find that in the routing table. And if you don't have a valid route, you won't find in the routing table. So this constraint is met in both the paths. You see, earlier the path via router 3 was also there for every network. Now you see only one. Let me try pinging this address with a source of 111, which is local to this router. Why I am not pinging? When I have the route, why I am not pinging? See, it will say I will send it to whom? Router 2. Let's go to router 2. Show IP route. What is the network? 68. It says I will send to router 4. Now where is the topology? Router 4. Okay, router 4 is autonomous system 20. Go to router 4. Show IP route. Oh, not this. Show IP route. It says you have to send it to router 6. Okay, we'll send it to router 6. Go to router 6. Show IP route. It says 68 is from router 8. And you have learned it through OSPF. Fine, it will send to router 8 now. Now go to router 8. It says it is locally connected to loopback 68. So there is no problem in the path. Now I'm asking you a question. From where this packet is coming, what is the source address? Please answer, one of you. Then why I'm asking question? You only should tell. My friend, R1's loopback. What is the address? Exactly. Now let us see whether the reverse path is available. Show IP route 1.1.1.1. Aha, aha, aha. You know why it is not there? Ledandi. We have advertised. I showed you, no? You see, I showed you when I type show IP BGP, I showed you it is advertised in router 1. See, the next hop address is local 0000, which means I'm advertising it. See, Bala cannot answer this because you were not in the previous configuration time, previous session. So, sir, only you have to tell me the answer. Why 11111 is not there in the routing table of router 8? No, sir, try something. Are we running BGP in router 8? No. Okay, sorry, we are running. Sorry, you're right. We are running. We are running. But the problem is, this is router 4's address. Is this reachable by router 8? Can you ping this next hop? That is the problem. You see this first point. Point number 1 is the problem. You don't have a valid next hop. So what is the solution? Self, where? On R6, correct. So let me go to router 6. Router BGP. This is the neighbor's address. Sorry, router BGP 40. Neighbor's address. Next hop self. Let us also do the same on R7. Router BGP 40 neighbor 10.78.78.8 next hop self. Now let us go to router 8. Wow. Now we have valid. You see the greater than symbol. Now check the routing table. Show IP route. Earlier it was saying no route. Now it says I'll go via router 6. So let us go back to router 1 and try pinging now. Earlier when I was pinging, the ping was not happening, isn't it? See, the ping was not successful. Yes, now it should be successful. Let us test it. See how quickly it pinged? Now let us trace the route. We are expecting the packet to go via router 4. Why? Because I don't have a neighborship between router 5 and 7. I have shut down. Earlier it was showing via 5. See, it's going to router 2, not to router 3. Bala, if you see this one dot 2, which is router 2. If you see 4, it is in router 4. No, R5 to R7. Okay. See, it is getting into router 8, autonomous system 40. Now let us unshut that R5, router BGP 30, and see, earlier I shut down here. Do you see that? I'm going to say no in the front of that line. This is how we unshut. After bringing this up, I'd like to go to R1 now and see the current route. It has gone back to router 3. You see that? Greater than symbol. Check the routing table. Router 3. Autonomous system 30. Now trace the route. It will go via down path. Sorry. As we expected. All right. What is next? We are going to see why it is going via the below path. Why not via the upper path? See, when I shut down, it went to upper path. But when I unshut, it came back to lower path. Why it didn't stay in the upper path? Both are having 2 hops, isn't it? Going via router 3 is also 2 hop. Wait. Going via router 2 also 2 hop. And why it is switching back? That is what we are going to find it out. Are you ready? See this. If both the paths have valid path, then it will come to this point. First point. Prefers the neighbor for whom the weightage is higher. Let's see the weightage now. Show IP BGP. You see, only focus on 68 network. The weightage for this and this is same, isn't it? Same. The weight is same. This is MED. Where is the weight? Weight attribute. That output it was shown. In this output, I don't see weight. Because weight, it is not industry standard. Weight is Cisco standard. That's why it is not coming in this output. So, anyhow, weight is a tie. It will go to the next one then. It prefers the path whose neighbor, which has got high local preference. Let's go and check any local preference here. Unfortunately, local preference is same, which means there is a tie again. So decision is not made based on the weight, based on next hop, based on local preference. Then what is the tiebreaker? Prefers the route originated by local router. Now, if you see, is it originated by local router? No. Both are learned from some other neighbor only. If it is local router, learned from will be 0.0.0.0. You see, for example, 1.1.1.1 is local network. Do you agree? You see the next stop. It is saying from 0000. So here, both are not local origin. So again, there is a tie. Next is shortest AS path. You see, the AS path here is 2 hop. Here also AS 2 hop. Again, there is a tie. So it is not because of MED, sir. It is not because of weight. It is not because of local preference. It is not because of local origin. It is not because of shortest AS path. Now go to the next one. Local origin code. IGP means I. Redistributed means question mark. Early days we had one old protocol called EGP, so nowadays you will not find it. So don't worry about it. Now it will prefer smaller one than the big one. That is our tiebreaker, my friend. You see, the one which is in this output, you don't see that. Origin code, you don't see that. So better go to normal mode, normal show IP BGP. You see, origin. This one has got I. Coming from router 3 has got I. Coming from router 2 has got question mark. Which is smaller? I is smaller or question mark is smaller? I is smaller. Lower is preferred, isn't it? That is why path via router 3 is preferred now. You see, greater than symbol. You understand why it is picking router 3 always? When router 3 is available, it cannot pick router 2 because the origin code I is more preferred than question mark. Is it very well understood, sir? Okay. Now what I'm going to do is I'm going to change this behavior because my policy is not going via router 3. My policy is all should go via router 2 only. Whenever I trace route any destination, 68 or 78 or 86 or 87 network, I prefer to go only via router 2. What should I do? See the very first attribute. What is the first attribute? Read. What is the first attribute? Wait. I am going to tune wait to achieve my policy. What is my policy? Going via 2 is my policy, correct? To any destination, if I trace route or check the routing table or BGP table, the best route should be here. The greater than symbol should be here. And here. And here. Right now it is not like that. Isn't it? Right now it is with router 3. I want a shift in this. I'm going to configure wait. Shall we see how to do it? See it. Router BGP. What is the autonomous system number? 10. Neighbor. What is the router 2's address? 10.12.12.2. Wait. Higher is preferred. What is the default wait? My dear friend, don't tell stories. Default wait is 0. Higher is preferred. So I'm going to give 10. And then clear IPBGP star soft. I'm refreshing BGP. Now let's check the BGP table, show IPBGP. Look at this, all got shifted because the wait is a tiebreaker. You don't need to shut down to switch the packets to the other path. Earlier I was shutting down the neighbor. Those things are not needed if you know this, isn't it? That's it. I just simply went and said router 2 is what I give more weightage. Router 2 is what I prefer more. Yeah. After I say that, you can see wait here. Show IPBGP. See, the wait that I configured is shown here. And this is the best path. You see, you don't see the word best here. You see only here. Let's check the routing table now. Show IP route for that network. You see, it is going via router 2. Now trace the route. It will go via router 2. See, it goes via router 2. We did not shut down any neighbor. In fact, if you go to BGP table, you will see both the paths, but only the best symbol is shifted to router 2 instead of router 3. Now, let me remove this wait. And refresh BGP table. And check the BGP table. You see now everything gone back to router 3 is next stop. Why? See the wait 10 is removed from everywhere. It has gone back to router 3 because router 3's origin code is I. Via 3, the origin code is I. Via 2, origin code is question mark. So the tie break is now gone back to the attribute number 5. Origin code is what? Attribute number 5. Don't forget. The sequence is very important. We tested wait. Now let us test local preference. Are you ready? For local preference, you can configure anywhere. You see, if you want R1 to go via router 2, right now it is going via router 3. You see, because I removed that wait, it will go via router 3. But not only router 1, even router 3 should go via router 2. Please understand my policy. Every router, including R1, including R3, every router in Autonomous System 10 should exit via router 2. If that is my policy, then I should not use wait. What I should use? Local preference. If I just got only one router, then I can go and configure wait. You see, please focus. Router 1 is going via router 3. Not only router 1, router 3 will also go via down path, router 5. Go and check router 3. Show IP BGP. Look at this. Router 3 says, I'll go via router 5. But I don't want this. I want my next hop to be 10.12.12.2. Do you understand, sir? Yeah. That is the story. But my policy is even router 3 should take this path. It should not exit like this. Yeah. So we are going to achieve using local preference. How to achieve this? So we are going to set local preference and change the next hop on every router. Meaning we are not going to go to every router to change this. We will just set local preference higher on router 2. When I set higher on router 2, automatically router 1, router 3 will start showing router 2 as the next hop. Right now, even router 1 don't show router 2. Even router 1 is showing only router 3 as the best next hop. Okay, how to do this? Go to router 2 and type router BGP 10. And I'm going to say BGP. Please see the command. Command is slightly different. You're already inside BGP, but you need to again type BGP. BGP default local preference. This is the syntax. Don't forget. For the wait, I was using the keyword wait, neighbor address, and then wait. But for BGP default local preference, I have to type BGP default local preference. And the default is 100. I'm going to say 150. See, earlier when you check in R1, you see default is 100, isn't it? Now I have changed this as 150. Sorry, this as 150. So that this will be best. I've changed 150. Let's check that. Change didn't happen. No problem. Go and refresh. Clear IP BGP star soft. Now you go back to R1 and check. You see the changes happened 150, 150, 150. We did in R2, and you see the impact in R1, and you see the greater than symbol has been shifted. And check the routing table, show IP route for 68. You can see it is going via router 2. Not only this router. Check on R3. Earlier it was showing router 5, but now clear. Clear IP BGP star soft. Okay, you know why? There is another rule we learned, you remember? Route learned from one IBGP should not be given to another IBGP. Do you remember that, sir? The route learned from one IBGP should not be given to another IBGP. Do you remember that? But in this case, the loop won't happen, so you need to say it is okay to give. How do we say that? We go to router 1 and say router BGP 10. You can give to neighbor 10.13.13.3 because he is your next hop client. Sorry, he is your route reflector client. Means you can reflect to him. Otherwise, you need to make full mesh. Either you make full mesh, yeah, route reflector client. Ask question, yes. You are overriding that rule. R2. Yeah. Now let us go and check router 3. You see, it is learning from router 2 and router 5, but it prefers to go via router 5. Why? Maybe this is unreachable for router 3. That is the reason. You remember, we don't have OSPF in between router 3, 2, and 1. Yes or no, sir? Please tell me. We don't have reachability, that is why. So let us run OSPF also. Interface Ethernet 0/0, IP OSPF 1 area 0. And I'll also run on R2 and R1. Router R1. Okay. Now, once the neighborship comes up, and then if you go router 3 and see, you will see even router 3 will try to go via router 2. That is what our aim is. Show IP OSPF neighbor. Two-way state, wait some time. El Shaddai. Okay. With router 3 and 2, okay, neighbors come. Now you go to router 3, 100%. The path will be via router 2. You see? Everyone has got shifted to the one which has got 150. You see that? You see that? So show IP route, you will see that it needs to go to router 2. For that, first it needs to go to router 1. Yeah? And then if it goes to router 1, it will show router 2. So local preference is if you want to change all the routers path, then use local preference. Only one router path, then use MAD. Now, we will not go to MAD or 6th to 11th, we will see later another day. But 1 to 5 itself we have to do in an advanced level in our next class. 1 to 5 attribute, no? We have done only basic level configuration. You set weight, you redistributed and you got origin code. You change the local preference. We did 1 to 5 today, only a basic level. We are going to repeat the same scenarios, but in a more difficult, advanced level with some real world example. I'll stop you.